Okay, hi everyone. Can you see the presentation?
Yes, please.
Yes, working fine. Okay, thanks, Victorio, for this short presentation. So yes, my name is Bastien. I am very happy to be here today for this workshop called Beyond Camera, New Ways to Communicate Science. And I'm particularly happy to be here because I am myself a postdoctoral fellow at the Center for Mind Brain Science, this center that is hosting this seminar today. And since the beginning of my career in science, I've been an open science enthusiast, I have to say. And even before starting my PhD, I was really interested in the open science practices, in the open science environment. And somehow this has led me to create a publishing platform that is called In&Sight, that aim to publish scientific experiments, scientific studies in a transparent, open, and dynamic way. And so, well, I'm still asking myself, how did I end up creating this platform? But I guess it's because I wanted to solve some problems that I have seen in science and in science publishing. And so in the first part of this talk, I will be focusing on some of the problems that I found in this world. So some would be related to the accessibility of science. Then there would be a small part about the file drawer effect. There would be also a part about the replicability crisis, some problems we have related to the transparency in science and specifically in science publishing. And then there would be a bit of time for me to present you In&Sight and what we are actually doing. It's a startup that I co-created with 3 other scientists and that we are now directing. And hopefully there will be then plenty of time for questions and open discussion after that. I like to start with these simple questions. What researchers do and what do they need exactly? And so as a scientist myself, I think I have the answer. At least for me, I'm always seeking for some new knowledge pieces. And I am trying to design experiments to understand the world that is surrounding us. And so I always try to create those designs to answer those experimental questions. But to do this in the best way possible, I think that we all need access to the scientific literature. We need to know what is done and what is not done. And more importantly, we need to know whether we can trust something or not. And I think that's probably one of the biggest problems we have at the moment, is that we do not have entirely access to all of the science that is performed in the laboratories. Well, we have a first problem that is well known. 50% of the literature is blocked behind paywalls. We will talk about that just after. And then we have a second problem, which is the idea that, the fact that there is a tremendous amount of experiments which are remaining unpublished, and that says it stays in the researchers' drawers. Well, the first problem, the fact that there is some percentage of the literature is blocked behind paywalls, I'm sure that you're all aware of it, because I'm sure that you've all tried to go and read an article on a website, read the abstract, potentially read a bit of the introduction or of the results section, then clicked on read more. And then when you clicked on read more, you probably have this purchase box that appeared saying, hey, you need to pay if you want to read more. I know it's interesting. Well, if you're lucky, your institution had bought, let's say, a subscription to that journal and you could access to it for free. If you were not, well, you just could not read the article, let's say, in legal way. Hopefully, this is a problem that we are getting rid of thanks to the open access license. So the open access license, I'm sure that you more or less know, all of you know what is it exactly, but I would sum up very rapidly. So it's a license that allows any content to be freely accessible to the entire community, so to everyone, and to be shared as well. It's not new because it was already used, I think, in the 70s by computer scientists. Then it was used in the 90s by physicists, and then it has spread to other fields such as biology or medicine. And as we can see, I was telling you that we're getting rid of the problem. We have a rapid growth of open access articles. So we have more and more access to the scientific literature if we look at the 2 last decades. Still, we have some that are closed, but we're getting rid of this problem. A little note, little aparté, if you're still wondering whether you should publish something in open access or not, I will give you this description that I think is very important, is the idea that it's the best license to distribute your research to the largest audience possible. So you might think, I want to distribute my research to a specific journal because it has a really high reach. Well, the thing is that there is nothing higher than open access, because open access is free access to everybody. And there is this good number, I think is important to notice, is that open access articles are 18% more cited than articles which are not. And I think that's a good number to remember. Okay, so now we can move on to the second problem, which is the fact that most of the experiments that are performed by scientists in the laboratories are in fact not published. This was termed as the file drawer effect. I like to call it the dark science. And it was already described in 1979, so it's a long-standing issue in science, and it's present in all of the sciences. And it's the idea that the drawers of the scientists are filled with experiments which are not published. And 95% for Rosenthal of those experiments are in fact non-significant results. So results which do not demonstrate any sort of effect. They are also called null findings, or in some cases, negative results. And in this work in 1979, so this was already some time ago, Rosenthal also described that the literature was quite the opposite of the file drawer effect, in the sense that it was composed of 95% of positive findings and 5% of type 1 error. And it was not so far in 1979 from the truth, because you will see from this report by Ellen and Meller that they had looked at the percentage of null findings in the literature, and they have found between 5 to 20% of null findings only. What's very interesting to notice and to compare is the percentage of null findings in the traditional literature in red here with the percentage of null findings in registered reports. So if you don't know what registered reports are, they are experiments, let's say scientific articles, that were registered before being actually performed in the lab. So the hypotheses were laid down, the material methods were laid down as well. And so scientists had to publish after that because it was peer-reviewed and accepted before they actually acquired the data. And in that case, what we found is really interesting, is that we found the opposite tendency. We found that most of the experiments that are performed are actually composed of null findings. And so, okay, it's good, it's percentage, but how much does that represent exactly? So if we take the current literature, we are on average between 10% of it on average null findings. And so this represents actually 300,000 null findings, which are published every year. But we also know from what we have seen just before on the slide before that we are lacking, let's say, a good 50% of the experiments. And so this means that we have at least 1.5 null findings, experiments with null findings, which are not published every year and which are buried in the researchers' drawers. And this is quite problematic, as it creates a misleading view of the scientific reality. Okay, so as we have seen, we do not have access to all of the science that is published because some are blocked behind paywalls. What is published is biased toward working studies, so significant findings, and we do not really have access to non-significant and other kinds of studies, but at least we can ask, can we trust what is published? And some scientists actually have said no, and this has led us to think that we are going through a reproducibility crisis, and that it's almost impossible to, or at least difficult, to reproduce scientific experiments. And so the open science collaboration that you can see here has led these experiments in which they have replicated 100 studies, which were published in 3 psychology journals. And what they have seen is that some experiments, you see here in green, could be reproduced. But what you can see as well is that at least 50% of the studies that were replicated could not be reproduced. The effect size was lower, and the p-value was turned not significant. So I think that this study was truly interesting, and I wanted to dig. And so I clicked on read more, as I was telling you before, and then I got this message. So just to show that even today, even a work that has been created by the open science collaboration has been published, but not in open access. It shows you that we do have really problems in science publishing today. But okay, we can move on. And now you might be wondering, okay, we have a problem in reproducibility in psychology, but what about other research fields? Well, we can look at another study that has been performed by Errington and collaborators. And they replicated this time 100 studies, but related to cancer, research. And what they found at the end is similar findings. They could not reproduce most of the experiments that were present. I think if I remember correctly from the article, it was around 70% or something like that. Okay, so what are the reasons? Why do we have a science that is not reproducible? Well, some scientists are arguing and thinking that it's because we have access to biased literature. Do you remember the file drawer effect I told you about? We only have access to what's working. We only have access to what's significant. And we do not have access to all of the trials we have made before as scientists, all of the experiments that we made until we arrived to that point and we managed to get something out. There is another reason. And this reason is the idea that most of the published studies, so the studies that have been published in scientific journals, even high impact factor journals, which are really famous, let's say, they do not provide enough research materials. And by research materials, I mean many things. I mean methodological details, I mean protocols, I mean access to the raw data. And this shows that we have a complete lack of transparency in science in general, but also in science publishing. And this is, I think, really problematic, as we have seen this morning in Enrico's talk, that transparency was a key and really key to science. So I think that there is one process over all of the other processes we have in science that represent well this lack of transparency. It's the peer review system, at least the traditional way that we do peer review. So as you know, in most of the cases, peer review is done blindly. So the authors are not aware of who the reviewers are and vice versa. Let me close that window because it's kind of noisy. Sorry about that. So we're saying that, yes, they are blind. So the authors does not know reviewers, and the opposite is true as well. And so they're having a discussion about an article that has been submitted to a journal. But what's really, let's say, not transparent is the fact that the peer review reports are actually staying in the hands of the journals, in the hands of the editors. And the discussion that might arise from the peer review process is just not available to anyone. Okay, it's just not there, doesn't exist. And I think that there is this nice infographic that illustrates how much time we are, let's say, spending on it and somehow losing. So if we consider that every year there is 3 millions of articles which are submitted, we have to know that 40% of them will be rejected after peer review. And so if we consider the amount of time spent by researchers, by peers, to evaluate those articles and to make sure that they are all right, then we can arrive to this enormous amount of hours spent per year. 15 millions of hours are actually spent on reviews of articles, which are not going to be published. And those peer review reports are also going to fade away. They're never going to be published, and nobody is going to learn from it. And I think that's quite of a problem, because to me, at least, peer review is exactly the right place to discuss science, to be critical, to be constructive, and to learn from each other, whatever it is. And I think that it can be only achieved if we move this publishing process towards something that is open, what we could call an open peer review system. And you will see that in In&Sight, in what I'm trying to develop, open peer review is the key to everything. And so, okay, we have many problems in accessibility. We have a problem in terms of bias, and we have a problem in transparency. So we might be wondering, whose fault is it? If we could point to someone, I don't know, Elon Musk, then it would be easy to solve, no? But in fact, the problem is not only one person, it's an entire ecosystem that we need to change. So for example, we have journals which until now have chosen, not all, but most of them have chosen novelty at the expense of reliability. And in turns, we have had researchers which have been focusing, for example, on positive findings rather than negative findings. And so we end up with this number, 60% of the null findings which are obtained in the laboratories are never written up. And we have had also institutions, universities, funding agencies, which have been evaluating researchers on the wrong metrics. They've been evaluating researchers on the impact factor, for example, of the journals where those researchers have been published, on the amount of articles published, and so on. So it's an entire ecosystem, and it's an entire loop that we need to change. And I want to be hopeful here. Things are in fact changing. And as we can see today with this initiative, with the Think Open initiative, we have institutions, we have universities, we have as well funding agencies which are willing to embrace and encourage scientists into using open science practices. And so this leads researchers to fight for openness, to fight for collaboration, to fight for transparency. And this can only lead to new platforms to be developed, as the one I hope I will be presenting today, In&Sight, but as the one that you will see after, for example, Octopus and many others that you will see after. So what is In&Sight exactly? So our initial goal was, in fact, to take all of the science that is not published, that is buried in the file drawer of the scientist, and to bring it to the site of researchers. And so to this aim, we have created this open publishing platform where we try to disseminate science in full transparency. And so exactly how does it work, you might ask? And what can you find on that platform? So we have taken more or less the traditional way that science is disseminating, because we have open access journals. And so, for example, for the life science journal, we have In&Vertebrates, but all of our journals have actually and follow a new publishing process without any editorial bias and permissive editorial line. So it means that researchers can decide to publish whatever they want. They can publish null findings, they can publish positive findings, they can publish replications, whether they are contradictory or whether they are actually able to reproduce something. They can publish reviews, methods and protocols, they can do registered reports, and so on. And they can do it the way they want in an open and dynamic way. And we will talk about that just after. So I'd like now to tell you more about, let's say, our article or our publishing process. How does it work exactly? So it has 4 main steps. And for all of the steps, we have tried to develop an online tool to help scientists not waste time and to help them share their science in the most transparent and open way. And so, for example, the first check is simply writing and submitting your articles to our platform. And so for this step, you will find, for example, this online editor where you can shape the article exactly as you want. You can either start writing inside the online editor, or you can even copy paste if you have done it somewhere else. And then you can shape it as you want. You can add different kind of media, so you can add figures, videos, audios, whatever you want. And you can directly and easily link the data to the figure and say, okay, for this figure, I use this data set. And under this data set, I use this code to analyze it. And if you really want to be transparent, you can also directly add the code in the text, for example, if it's something that you want to highlight. So you can really do what you want, and you can really be free in the form that you want. Then obviously we're going to run some checks, because I think that it's important. Open science is very important, but we also need sometimes to do some sort of controls. And so we make sure that the authors are really researchers, for example. We do not publish articles with cat's name, as it has been done in the past. We test for plagiarisms, as I can tell you that there are a lot of plagiarism out there as we are sharing more and more content. So we have to control some of the few things. But if an article passed the quality check, let's say the pre-checks, which last from, depending on the article, from 1 day to a couple of days, 1 week maximum, then the article is going to go into the second stage, which is the enhance, what I like to call the enhance preprint stage. At this stage, the article is made available publicly. Everything is transparent. You have a DOI so that it can already be cited as a normal preprint. But there is a mention that says that you have to pay attention, however, because this manuscript have not yet been peer-reviewed. So you have to wait. And then there is this second section, this, let's say the two, not the second section, the 2 last processes, which are linked to one another, which is the open peer review system and the correct and updates phase. So the open peer review system is going to happen once we have released the article as a preprint. And we are going to, the editorial team that is behind In&Sight is going to look for reviewers with very specific expertise and going to ask scientists whether they are willing to review it in full transparency. This means that they will know the name of the authors. It will also mean that the authors know the name of the reviewers. Everything will be transparent. Everything will be stated. And the discussion that will be created between the peer reviewers and the authors will be made public alongside the article. And this will lead to hopefully a constructive discussion, whether you are having different opinions or whether you're agreeing or not. And this will lead to a correct and update phase where the authors can actually slightly change the article and update it. And I wanted to give you an example of that, because I think that's really the key thing within In&Sight. So here we have this article that has been submitted and then we published by Leslie Rogers, with a specialist in lateralization in vertebrates and invertebrates. And she submitted the work. It was a review with a very interesting questions. So can you see it here? Okay. And so it's been peer reviewed. So we invited 2 reviewers, and you can have access to review on the right side. And so here you see the first peer review. Then you have the second peer review here. And then you have the response to the reviewer by the author. And you see that it was quite a fruitful discussion. And what's very interesting as well, I believe, is that we keep all of the versions of the articles. And so you can go back to a previous version and see what has changed. And you can therefore, based on the feedbacks from the community, based from the reviewers, you can always make your article more accurate. And so you have these sort of dynamic articles. And so we are going in that direction, trying to always have articles that are fully transparent and that can always be more precise and so on with time. And what's very interesting as well, at least from this, was that, as I was telling you, one of the reviewers of this article did not really agree with what was said in the paper. It was having some sort of another idea, another opinion, and this has led to a very constructive discussion. A constructive discussion, to me, that add a lot of value to the article, and that builds the reputation of the own article outside of the journal's name. So it means that through open science practices and transparent practices, one author and reviewers as well can build their own reputation of the articles and as experts in field outside of the journal's names. And I think that's very important today in science publishing. Okay. And so in summary, what In&Sight does, it publishes your science in transparency and is doing it, let's say, rather rapidly. Then through In&Sight, you can try to build your own article's reputation through an open peer review process, while as well embracing open science practices. So you can decide to publish null findings, whatever you think is interesting, and that should be shared with the world. Now I'd like to probably end this talk with a fundamental question that was raised by Michael Nielsen in a TED talk about open science back in 2000, I think it was in 2011. So more than 10 years ago. And 10 years ago, Michael Nielsen asked to many different people, researchers, scientists, non-scientists, people working at institutions, universities, many coming from very different perspectives. He asked, what kind of knowledge are we going to expect and incentivize scientists to share? Are we going to continue as we did in the past, doing it in an opaque way and in closed way? Or are we going to go towards more collaboration? Are we going to embrace open science practices and open publishing practices? I think it's a question that we can all ask ourselves, and we can see in 10 years what happened. So I'd like to thank you for your attention. I would like to thank the Think Open initiative for this invitation. I was really happy to be here to present In&Sight today. 2 more news. We have recently released our first special issue on the evolution of cognitive traits. So if you're interested, you can just go on the platform and read it. And we are about to launch a second special issue on timing perception. So as well, if you're interested on this topic, you can just reach out and you can see what we can do. And I'm going to leave you with this nice animation. And if you are a PI, you need to know that you don't need anymore to explain to your students that the paper is going to be going into the lab drawer, because there are now new platforms and new ways to disseminate your science wide in the open. Thank you.
Thank you. So I'll put this in the chat. So if you want to ask questions, just put in the chat you can type question and we will call you on screen. Or you can just type the whole text of the question here and we'll read it aloud. I think I already thanked you, Bastien, for this very nice presentation. I would start with a question. I was interested in your passage about plagiarism.
Mm-hmm.
Is this like sort of, do you use a third-party service?
Yes.
It's just a check, or it's a...
No, so we're using actually two different softwares. So when you attribute DOI to a content and to a scientific article, you can do it with many platforms. And so we have chosen let's say the most famous one, which is called Crossref. And so Crossref is also linked to something that is called Crosscheck. And this allows publishers to simply run plagiarism tests with everything that has been published in other scientific journals, because all of the journals are connected through this platform. And then we use another software to control for that as well. So we run twice the plagiarism test. And then hopefully we get a percentage number that says, okay, this part has received some plagiarism and so on. So yes, we do use third-party softwares for that.
Thank you. So there are a couple of questions. One by Alex Freeman, and then the next speaker.
An important question I've seen.
How are you funding the work? Do authors pay a publication fee?
Yeah, so for until now, we've been only working on our personal funds. So everything that we have done has been put from our own pockets. So the 4 scientists that have created this initiative, the money comes from there. And then for now, what we work on are APCs, as many other open access journals, but we have reduced it to the minimum possible so that the platform is sustained through time. So the idea is to not make money. It's not for profit. It's a not for profit. So the idea is just being able to maintain the platform a long time and provide new services with time as well. I have to say that we're also open to any other forms. The best of the best, and I have to say, because I believe in it, would be to have something that is free and free. But if you want to develop something and make it sustainable through time, there will be always at some point in which you will need to have funding, whether it comes from an institution, whether it comes from whatever funding agencies, whatever, but there will be a time in which you will need that money to maintain and sustain something through time. So for now, it's an APC that is 3 times lower than the average you can find in other open access journals.
Thanks. I think what like a complete answer to this question. I would read aloud another question by Paulo Santos. Hi, Bastien. This is a great initiative. There are other similar platforms out there which share the same ambitions and functionalities. However, without governmental, and academic support, it's quite hard to make this transition. Do you think that establishing some sort of agreement with impacted scientific journals could somehow facilitate the introduction of these practices into research culture? Thank you, Paolo, for the question.
Yeah, I'm reading it again to make sure that I'm not losing anything.
So, as I understand the question, I think it's something that relates to joining other scientific journals and then maybe becoming a sort of open access online journal section of something which for now has an higher impact.
Yeah,
but that's my interpretation. I don't know if Paolo...
Yeah, no, I read it as well. I was reading it to make sure I was not forgetting any part from it. Thank you, Paolo, for this question. Yes, I think that there are a lot of initiatives which are being started at the moment. I have to say that, for example, there is at the European level, there is this publishing platform that has been created as well, and there are many others. And there is always something that you think you can add, something you can do. And at first, before we started this, nobody was really focusing on the file drawer effect, and we had started at this stage thinking we are going to focus on the file drawer effect. But then our things, let's say, grew, and we ended up thinking, okay, we need to open it in a way. And I kind of agree that we could have something that is common and probably would be helpful, but at the same time, it will reduce the amount of possibilities that we could have to share our science. I think that many ways we can share our science, and that having the freedom to choose from many different services is also a good thing. So there are pros and cons, I would say. The only thing that is truly important is to have many services which are in line with open science practices. That's what I would say. Then whether something is grouped or not is up to everyone to decide.
Thanks. So there's another question by Carlo Minus. I don't know if Carlo wants to ask.
Yeah, I mean, normally one element that takes a lot of time is the reviewing process, and we get requests every single day to review a paper. So I was wondering if you found any problem in that respect, also because this kind of reviewing is even more demanding in terms, et cetera, et cetera. So I was wondering if you found any problems in finding reviewers, and
yeah, so
how do you solve it?
Yeah, thank you for this question. And it does take a lot of time. Finding reviewers is not an easy task. And I've been searching for most of the reviewers that we have had on the platform until now. And I remember for one article, I had to contact more than 17 researchers before getting to get 2 person. And it's not, I mean, I was not happy to contact people to ask to review for free. The only thing that I have to say, and probably the only difference, is that with a transparent process, it takes time, but then you get the reward of building your own reputation, of working in a collaborative environment. In this way, there is the reward for the author, and there is the reward for the reviewer as well, which is not essentially the case right now. If it's done in a really opaque manner, you just get your name at the end and say, oh, I reviewed for +1, or I reviewed for +1 probably open, I reviewed for, I don't know, another research name, journal's name, and you don't get any reward from that. So I think that's the pros of this system is to build your own reputation of the article and as a reviewer as well, and by showing off that you are doing open science and you are doing it in the wide in the open. So it's complex, and we need to find new ways as well to probably have reviewers more easily, I guess. But I mean, having a service that does that would be helpful for sure.
Thanks. Actually, okay, yeah. Please, Paolo.
Yeah.
Hi, thank you, Bastien. Sorry, I managed to fix my microphone. I just wanted to elaborate a little bit better on my question. So my point was more or less like this. Research institutions and researchers likewise, they are unfortunately mostly evaluated from a scientific point of view based on metrics, bibliographic metrics, you know, like your H index, etc., etc. And I think that, unfortunately, for this sort of initiatives, one of the problems is that in those platforms that do have an index associated to the document that is published on that platform, these indexes are not recognized by governments, by universities, at least not until now, of course. Mm-hmm. And so I think that sometimes this is like a deterrent, you know, like researchers don't feel so much motivated to perhaps publish an article in your platform in this case, as opposed to publishing it in a journal. Because working in a research institute myself and knowing how we as a research institute are evaluated, in this case we are evaluated by the Italian Ministry of Health. They have really strict evaluation criteria that you have to respect. And it goes beyond, of course, our national case. It goes also to the international community. So that's why I asked, could it make sense like to strike a sort of agreement with scientific journals? I don't know, perhaps like maybe I'm just daydreaming, but perhaps it could be possible to, I don't know, make the peer review process on these platforms, keeping a version of records and making the peer review process open and available for everyone, and then publishing the final, in this case, we don't actually have a final version because it could be potentially always, updatable. But yeah, but then if you could publish it somehow in one of these journals, then at least you would still have that, you know, that factor in those indexes that the researchers so often aim at.
Yeah,
that's basically it. Thank
so
you.
if I have to thank you for precising what you were saying, I have to start and jump in on the impact factor. We are clearly speaking about the impact factor right now, and there are many institutions, many universities who are going away from it. There is the Declaration on Researcher Assessment, the DORA, which has been signed by I don't know how many, but thousands of universities, and they are not using it anymore. And so we are truly now going away from this impact factor, let's say, number. And so we are in transition. That is true. There are still institutions who are using those kind of things. Then I have to jump in on what we are doing. We are exactly in transition as well, because we have a journal. So I was telling you about In&Vertebrates. In&Vertebrates is the life science journal of the platform, let's say, that is hosting it. And so we are having some sort of metrics to measure, let's say, the activity of the article. So how many peer review it has received, how many answers, how much time it has been updated. And so there will be metrics that people could use then to measure, let's say, the efficiency, or let's say how much has been widespread, how much has been helpful to the scientific community. And I think we need to change that. And I think that's it's an entire ecosystem that we need to change. Hopefully, not hopefully, but unfortunately, things are not changing very fast, and it takes time, because we need to change publishers, we need to change journals, we need to change the universities, we need to change the institutions, the funding agencies, and how we are doing things. And it's a process that takes really a long time, I would say. But we are definitely going there. And I think that it's something I always speak with scientists, especially with senior scientists, who have the tendency to say that young scientists must publish in our impact factor journals if they want to move on. And I think it starts there. It starts with senior scientists. It starts with scientists saying, no, what matters is to publish a science that you can trust, a science that is transparent, a science that is beneficial to the scientific community. And it's by little things like this that we are going to be able to change things. And yes, it takes a bit more of effort today, but I think that we can achieve great things tomorrow. So that's what I would say. Thanks.
Thank you, Bastien. Thank you.